we already know that x and y have joint density function, which is fxy equals to 1 plus xy divided by a when x is ranging from -1 to 1 and y is ranging from -1 to 1, 2. And fxy simply equals to 0 in other conditions. So the first question is that we should find a so that fxy has a valid joint density function. That is to say, the integral of fxy dx dy equals to 1. So in this case, we can make an explanation that is -1 to 1, -1 to 1, 1 plus xy dx dy equals to 0, equals to 1, and the result should be 4 divided by a equals to 1, and a should be 4. So in this case, we have find the a that makes the density function to be valid. The second question is we have to show that whether x and y are correlated or uncorrelated. In this case, we have to first figure out the aspect of xy and the relationship between the aspect of xy and the expectation of x and ey together. So in this case, the exy actually equals to 1 divided by 4, the integral from -1 to 1, -1 to 1, xy times 1 plus xy dx dy. And the result is 1 divided by 9. And that's the expectation of x times y. Then we have to figure out ex and ey. In this case, ex equals to -1 to 1 minus x times 1 plus xy dx dy, and answer should be 0. In this case, as follows, ey equals to 0, 2. So in this case, ex times ey actually equals to 0, and that is not equal to exy. So in this case, we can draw the conclusion that they are not uncorrelated. Then the question 3. Are x and y independent? Since they are already not correlated, they can never be independent. So x and y are not independent as well. Then the fourth question. Find the joint density function of x squared and y squared. In this case, we have to use the two function of random variable fundamental theory. That is, we have to make z equals to x squared and w equals to y squared. In this case, the Jacobi should be j equals to partial z, partial x, 0, 0, partial z, partial w, and answer should be 4xy. And also, we know in order to satisfy this function, the xy have 4 roots. They are namely z square root, w square root, z square root minus w square root, minus z square root minus w square root, and minus z square root w square root. And that's the 4 roots of this function. So in this case, we can simply apply the fundamental theory, that is, the joint density function of zw equals to fxy divided by the absolutely value of gx1y1 plus until fxy x4 y4 divided by the Jacobi of x4 y4. absolutely value. And the answer should be 1 divided by 4 times the square root of z times w. In this case, we have find the joint density function of x squared and y squared. Then the question 5. We have to prove or disprove the x squared and y squared are independent. In this case, we should firstly find are they uncorrelated or correlated. So in this case, we have to actually in this case, we have a simple rule, that is find the marginal density function of fz and the marginal function of fw. We should figure whether the joint function fzw equals to the marginal function, whether or not. So in this case, we firstly know that the joint function of fzw actually equals to 1 divided by 4 times zw squared when z is ranging from -1 to 1, w is ranging from -1 to 1, and equals to 0 in other conditions. So in this case, we can simply find the marginal function of fzz equals to -1 to 1, 1 divided by 4 times zw square root dw. The answer should be 1 divided by 2 times z square root. And as follows, the marginal function of w, fw actually equals to 1 divided by 2 times w square root 2. So in this case, we have already found that the marginal density function fz times fw actually equals to the joint function of z squared of z and w. So in this case, we know that z equals to x squared and w equals to y squared are independent. And that is the answer of the question A. That's all. Thanks.